I'm going to look at my like terms, 8x and negative 2x. They're on the same side, so I just combine them. Rylan, what you doing back there? You okay? All right. 8 minus 2 is a positive 6, plus 15 equals negative 45.
Wait.
They're on the same side, so I just combine them.
Okay, never mind.
Yep. I'm going to subtract 15 from both sides. 6x equals negative 60. Quite a few people were getting this whole situation wrong yesterday. Guys, please use your calculators. I beg you. Open up your iPad. Use the calculator. Yes, absolutely.
Yes.
Wait, are we allowed to use our calculators on every test from now on now?
Yep.
Oh.
Oh yeah.
X equals negative 10. Question 2. We did this yesterday, so I'll go quickly. Like I said, I'm going to subtract these. I get negative 4x minus 2 equals negative 4x minus 2. If I add 4x to both sides, I'm left with negative 2 equals negative 2, which is infinite solutions. Number 3, no distributing, no fractions, no decimals, but I do have like terms. Negative 8x minus 10 equals negative 8x minus 3. Add 8x to both sides. Negative 10 equals negative 3. Nope. No solution. There will be one of each of those on the quiz as well. And they're on the study guide number 2. Just saying.
Yes.
Extra practice. Okay, number 4. This is our extreme equations. I do need to distribute. So 1/4 times x is 1/4 x. 1/4 times 5 is 5/4. Everything else stays the same. I'm going to clear my fractions. What is my least common denominator? 8, because 4 goes into 8. 8 can go into 8. So everything gets multiplied times 8. Even this negative 15. Don't forget that guy over there by themselves. So I have this term, this term, this term, and that term. One times 8 is 8. Divide by 4. 2x. 5 times 8 is 40. Divide by 4. Plus 10. 7 times 8 is 56. Divide by 8.
7.
So minus 7x equals negative 120. Got my like terms. 2 minus 7 is negative 5 x's. Plus 10 equals negative 120. Subtract 10. Negative 5x equals negative 130. Divide by negative 5. X will be positive 26. How are we doing? We're going to do great tomorrow. No, not going to happen.
Persevere.
We're going to persevere. We're not giving up, right? We're going to accept the challenge, overcome.
Smash that like button.
Smash the like button, like and subscribe. It wouldn't be so funny to me if like every episode, everything my boys watch right now is on YouTube, which drives me bonkers. because I constantly have to monitor them because my 5-year-old will inevitably end up on something that's like, no,
YouTube kids.
you should not be watching that.
YouTube
That's
kids.
your solution.
He's pretty savvy. Like he says he doesn't know what he's doing, but I know he knows what he's doing. So
Yeah, my little brother watched Laser Beam and I got in trouble for it.
I don't
What?
know. Laser beam? I don't know what that is. But like he'll find YouTubes of like people playing pranks on each other, and it's like you need to not be watching things like that. I don't want you playing pranks on me.
That'd
So
be so funny. Sorry.
hilarious.
I just put on Blippi
It's
for
like
my
Billy.
brother and he's fun.
Retaliation. if you
Blippi's legit. Yeah.
Yeah.
Okay, so we have inequalities, which is the same as equations, except we have this little symbol here, and we have to graph. So maybe not the same, but pretty close. Do I have to distribute here? Sure do. So I'm going to get 10x plus 2 minus 15 is greater than 3x minus 27. Do I have any fractions? Do I have any decimals?
No.
Do I have any like terms?
Yeah.
Sure do. 2 and negative 15. So 10x minus 13 is greater than 3x minus 27. Now I'm going to isolate, so I'm going to subtract 3x from both sides. Get the variables all to one side of that seesaw, teeter-totter, right? 7x minus 13 equals negative 27. Oops. Thank you, Brody. Not equals. Is greater than.
Good job, Brody.
So I'm going to add 13 to both sides. I get 7x is greater than negative 14. Divide by 7. X is greater than negative 2. I do not flip my sign because I did not divide by a negative.
Oh, it's only if you have two negatives?
It's only if you, well, it's not about having two negatives. If this number that I divide by is negative, then I flip the sign.
Oh, so the bottom number?
The bottom number has to be negative.
Okay.
So then I've got my negative 2, my 0, and my 2. Open or close circle?
Open.
Open. Shade to the right or the left?
Right.
Yep, these are all the numbers that are greater. All right. Number 6.
Number 6 is confusing.
I mean, there's a little bit to do there. So we've got our wall of equality. Do I have to do any distributing?
Yes.
Sure do. So I'm going to get negative 6x minus 4 plus x is less than or equal to 6. Do I have any fractions?
No.
Decimals?
No.
Like terms? Yes. So I've got this here. Negative 6 plus 1 is going to give me negative 5. Minus 4 is less than or equal to 6. I'm going to add 4 to both sides. Negative 5x is less than or equal to 10. Divide by negative 5. So Brody, what do I have to do?
Flip the sign.
Flip the sign. Open or close circle?
Close.
Close. Good job. And I'm going to shade my arrow to the right again.
So the circle is closed if it's like greater than or equal to?
Correct. Or less than or equal to. If it has that or equal to situation,
Yeah.
that's when you fill it in.
Okay.
Yep, that means it can be that number. That's the universal symbol in math. All right. Let's find some mistakes, shall we?
Wait.
Yep. Can you see something?
No.
Okay. Jillian, how you doing? Zoe? You with me still? Yeah. Emma? You okay over there? It is really bright. Okay. Where did this student go wrong? They had a good thing going and then they made a mistake. Mia.
Wait. Sorry, I just said something. I know the mistake is missing.
Okay. Oh, so someone else go? Sophia. They didn't combine like terms correctly, right? So this should actually be what? Not 16x, but it should be positive 8x. So the student did not combine 12x and negative 4x correctly. Now, there are a lot of different ways you could explain to me what the student did wrong.
I said the student should have subtracted the 12x and the 4x.
Perfect. Right? So your answer doesn't have to look exactly like mine, but it needs to make sense with what's actually wrong. Okay, so if I know you know what you're talking about, you're going to get the point. Also, I mean, there's a lot of different places you could have circled up here. You could have circled here to show that, like, they didn't do that right. I'm going to know if you knew what to circle. Like, I'm going to know if you're on the right track or not. So don't get too concerned about what you circle, okay? All right, so now let's solve this correctly. It's a super ugly answer, but we'll go through it. I'm going to distribute the 4. And then I'm going to do the correct way of combining like terms. Then I'm going to add 28 to both sides. Divide by 8. And this is my ugly answer, 23 over 8. All right. Number 8. Who can tell me what was this student's mistake? I mean, they started out strong. Then they made a rookie mistake. What was it, Maggie?
They did negative 7 times negative 5, and they said negative 35, but it should be positive 35.
Correct. Negative 7 times negative 5 should be positive 35. Right.
Will these be on the quiz?
Sure will. The quizzes are always very similar to the study guides.
So it's going to be 5 pages.
Sure is. But come on, this is like one problem.
Yeah, that's true.
So it's not, I mean, 5 pages sounds pretty miserable, but this is just one problem.
Yeah.
It just happens to take up a lot of space.
It's a long one.
All right, so they multiplied both sides by 3. These canceled out. So we're left with negative 7 times the quantity x minus 5 is greater than negative 27. I did see some students distribute first. That's fine. I mean, you can distribute before, distribute after. It's okay. Got my wall of equality. Negative 7x plus 35 is greater than negative 27. Subtract 35 from both sides. Negative 7x is greater than negative 62. Divide by negative 7. So what am I going to do here, Brody?
Wait. Flip the sign.
Flip the sign. And it becomes a positive fraction because a negative divided by a negative is a positive value. Hopefully you're feeling pretty good. Like tomorrow's not going to be so miserable. You're going to walk in here and you're just going to show me how smart you are. Yes.
That's exactly what
Why would we, if we're not dividing anything, then why would we change it to a positive?
Well, that's just how you would simplify it. So that would be the next step to simplify it. Is that when you have two negatives, that means it's actually a positive value.
Why would you keep it?
Because this is really important for algebra, that you leave things as simplified improper fractions. So I'm like forcing you to do it now. Because there's nothing worse than when my algebra students come up to me from having pre-algebra in 7th grade and they just want to put everything into decimals. It drives me crazy.
So is it?
I actually write boo on their papers when they put something as a decimal. I don't count it wrong, but I definitely let them know how I feel about it. What? What was that, Ben?
Huh?
What did you say?
I remember Landon got that. I was wondering why he had boo on his paper.
Yeah.
That's why.
I'm not like going to change the grade, but I'm not happy about it. I wrote boo on your sister's paper plenty of times. She likes to change things into decimals. Okay, here we go. Scientific notation. Remember, the exponent tells us how far to move the decimal, right? We have to put things into proper scientific notation. So I'm going to put my decimal after this 4. And I know that it would be 2 places to the left to get it back to where it started. So 4.056 times 10 to the negative 2. Because I have to go to the left. And your decimal has to be after 1 digit. Do you guys remember that rule? A single digit? Sure.
Yeah, I remember that.
Thank you. So then I'm going to put my decimal here, 1, 2, 3, 4, to get it to the back of the number. 1.35 times 10 to the positive 4, because it goes to the right. I think you're going to want to do this section of the second study guide there, Brody. Yes?
Why couldn't we start from the left and go to the right? Like, do we always start at the zeros?
So you're always going to go after the first. So if it's a number that's greater than 1, you're going to go after the first digit. If it's a number less than 1, like this is that value, you go after the first digit and you move it to the left.
Okay.
Yep. All right, so 1.12, positive 4, so I go to the right 4 places. So this equals 11,200. I've got a negative exponent here. So I'm going to go to the left 1 place. So I'm going to get 0.723. You don't have to put the 0 point, but I like to put it there so people know that that's where my decimal is. Is it all coming back to you, your love of scientific notation?
No.
How about this? Exponents.
I can't.
Woohoo! What do you do when you are multiplying exponential expressions that have the same base? Add them. Nice job, Maddie. So I'm going to get 3 to the 3 plus negative 5. So what is 3 plus negative 5? 3 to the negative 2, but I can't have a negative exponent. So who remembers
the fraction thing?
the fraction thing?
Jonah, you're so smart.
1 over 3 to the second power. Cannot leave it as a negative exponent. That changes it, because if I put in my calculator 3 to the negative 2, that's going to equal if I did 1 divided by 9. It's going to be the same value. How about number 6? What do we do when we have exponents and we're dividing? Subtract the exponents. And you guys know I'm not going to make this super easy on you. 9 minus negative 3. I add them. 8 to the 12th. Put Equal sign there, I'll stay consistent. What do I do when I have a power raised to a power? Multiply. Ferdy, are you just guessing or do you really know these?
Guessing.
Well, if you're just guessing, you're a good guesser. 8 times 4, so that gives me 7 to the 32nd power. There's no funny business there.
Does the exponent need to be under 10?
Nope. Nope.
Oh, no, the whole number does, doesn't it?
The whole number can be any whole number. With scientific notation, though, this has to be a 10 always. Yep, I think that's where you're getting that. All right, and then I'm going to subtract these again. Two to the 7 minus 7. What is 7 minus 7?
0.
Anything to the 0 power equals?
0.
1.
Come on, guys.
0 power rule. Look at all the exponent information I got into those 4 small little problems. We've got adding, multiplying, subtracting, negative, and the 0 power. You're welcome. Okay, now you guys get your study guide number 2.